Among the most transformative discoveries in modern longevity science is the realization that aging is not just a result of time passing, but deeply linked to a measurable biological shift inside our cells: the steady decline of NAD, nicotinamide adenine dinucleotide. This coenzyme, present in every cell of the body, is essential for converting nutrients into usable energy, repairing damaged DNA, regulating inflammation, and maintaining healthy mitochondrial function. When NAD levels fall, almost every system that keeps us resilient begins to weaken, and signs of aging, from fatigue to slower metabolism to impaired cognitive function, start to emerge more clearly. Understanding why NAD declines and how vitamin B3 precursors may help restore it opens a hopeful new chapter in strategies for healthier aging. Research shows that NAD levels drop significantly as we get older, in some cases falling to about half of youthful levels by middle age and continuing downward from there. Several factors fuel this decline. First, NAD is consumed rapidly during DNA repair, a process that accelerates with age because of cumulative exposure to stressors such as pollution, UV light, poor sleep, and everyday metabolic stress. Second, chronic low-grade inflammation, commonly referred to as inflammaging, increases the activity of enzymes that degrade NAD more quickly than the body can replenish it. Third, mitochondrial efficiency decreases with age, requiring even more NAD for energy production while simultaneously producing more oxidative stress that further drains the supply. With each passing year, the body fights harder to maintain balance, but without enough NAD, cells gradually lose their ability to repair, regenerate, and perform optimally. This is where vitamin B3 precursors, such as niacin, nicotinamide, nicotinamide riboside, NR, and nicotinamide mononucleotide, NMN, have captured scientific attention. These compounds serve as building blocks that the body uses to produce NAD naturally. Unlike direct NAD supplementation, which does not absorb efficiently, these B3 derivatives can be converted inside cells into usable NAD, helping to replenish declining levels. Human clinical trials have shown that daily supplementation with NR or NMN can meaningfully raise NAD concentrations in older adults, supporting improvements in metabolic function, muscle strength, cardiovascular markers, and energy levels. What makes this particularly compelling is the multi-layered effect. When NAD levels increase, cells regain the resources they need to repair DNA damage quickly and accurately. This reduces the risk of dysfunctional or senescent cells, which are known to accelerate aging and inflammation. Higher NAD also activates sirtuins, proteins often referred to as longevity regulators, because of their roles in metabolic efficiency, stress resistance, and genetic stability. In addition, enhanced NAD helps mitochondria work more effectively, improving energy production and reducing oxidative stress, which is a major contributor to cellular aging. This shift in cellular vitality can translate into real, observable benefits. Trials have reported improvements in endurance capacity, insulin sensitivity, vascular health, cognitive markers, and feelings of physical energy. People frequently describe a subtle but meaningful return of clarity and stamina, suggesting that restoring NAD is not only about extending lifespan, but about preserving quality of life. Instead of accepting age-related metabolic decline as inevitable, researchers now believe we may be able to slow, or even partially reverse it. Of course, vitamin B3 precursors work best as part of a larger foundation of healthy behaviors: nutritious food choices, regular movement, restorative sleep, and effective stress management. Foods such as poultry, tuna, salmon, mushrooms, avocado, and peanuts naturally provide niacin, supporting daily NAD maintenance. For those exploring supplementation, selecting high-quality, well-tested products and understanding appropriate dosing is crucial as research continues to refine safety and effectiveness guidelines. The most encouraging aspect of this science is the optimism it brings. Instead of viewing aging as a downward slope, we may begin to see it as a process that can be influenced through intelligent, biologically informed choices. NAD research suggests that our cells possess remarkable repair capacity when given the right tools. Vitamin B3 precursors stand out as promising allies, offering the potential to preserve vitality, metabolic strength, and cognitive resilience for longer than previous generations believed possible. In many ways, this shift represents a new frontier, one in which aging is not just endured, but actively shaped toward a healthier and more energetic future.